Yeah, good morning, everyone. Welcome to the German hour. Christian is on the next room talking about React.PHP, also from Germany. I'll do my very best. Yeah, let's talk about testing. I did this talk once already together with a more famous Sebastian in the PHP community, which is Sebastian Bergmann. And most of you probably know him because he's the one who created and still maintains the PHP unit testing framework. And well, unfortunately, when I got on a plane from Hamburg yesterday, he's living nearby, and flew over to this nice conference, he took the other direction and flew over to PHP Central Europe, I think, which is in Poland, which probably also is a nice conference, but well. Anyway, I want to talk about testing. And most of the time when people start learning about how testing works in PHP, they see relatively simple examples and they take it back to their own projects and then they realize, okay, for me it's not that easy. And all the things I learned there, I cannot really apply to my code. So of course, testing clean code and simple code is very easy and we can all do that. But the reality is that most of us really deal with old code, legacy code. And testing legacy code usually is really hard. And I'll show an example from the company I work for. And I'll show some slides of what we do as a company, and that's not really meant as advertising. And you will realize that as soon as I show actual code from our company, because that certainly isn't advertising us, but it's reality. You know, we all deal with those kinds of problems. So let's quickly talk a bit about the domain. And this is our website. So the company is called Kartenmacherei, and what they do, or what we do, is we have a web-to-print business where we send out wedding invitations and birth announcement cards, stuff like that. And that's very popular in Germany. I don't know how it is in Scotland, but you know, when you have a child, you usually send out a nice printed cards to your friends and family announcing the birth of your child. And the same goes for invitations for weddings, save the date cards. So there's a lot around that. It's actually quite a huge market in Germany. And yeah, this is what we do. So you can go to our site, and I think the batteries are a bit weak. Go to any design you like. So this would be one of the birth announcement cards. You have certain colors and formats and all that stuff, and then you can customize them. So you have a configurator, you can upload images, you can change text, you can order as many cards as you need, and there are more advanced features like laser cutting, so you have round edges and stuff. Just as some background information. And what's happening behind the scenes is something like this. So our designers create card designs in something like Adobe InDesign. They export that into a certain format, which is called IDML, which is really just a collection of XML files bundled in an archive, describing the whole card there. And then our software comes and imports this IDML, parses it, and creates other artifacts out of that. The most important one is this FO file up here. Oh, I have to do it on both sides, right? Which is a different kind of XML which you can use to create PDF files. So it's Apache FOP as a standard. So that's the main tool we use for creating PDF data, which is then sent over to a printing company, which does the whole printing and packaging and sending it to the customer for us. Along the lines, we also create some images, like the preview we have on our product detail page, other previews from what the customer created. So this is one part of a process that we will have a look at in a moment. The second part is what the customer actually does when he opens such a card in the configurator. So he does that in his browser, and he uploads images, and he changes text, and then at some point he saves that, and hopefully also orders the card. And that will essentially update this FO file with the customer's data and with references to images he uploaded, which will then again be rendered into a PDF and maybe some preview images. And this is a relatively simple process when you look at it at this high level. But of course, the devil's in the details. And when the company started doing this roughly 7 years ago, it was really a very small family business. So it was actually a family who just got a child and they wanted to have this birth announcement card. They couldn't find anything nice, so they did it themselves. And they got so much nice feedback that they said, okay, maybe we can make a product out of this. And then they talked to a developer, and they did like a prototype with him. So this one developer sat down and pretty much established this process. So he figured, okay, I can use Apache FOP for creating PDFs, and we can use this. And then they just wrote down some PHP code to do all that for them, and they used some standard e-commerce framework to set up a shop and start the business, actually. So they started on a very low scale, as it's usually the case with startups. So you can probably already imagine what the code might look like, not only because it's 7 years old, but also because it's coming from this very small setup, one developer sitting there just trying to make it work and to get like a proof that the business actually works. So over time, the business grew. It grew very quickly, and we introduced more and more different kinds of products. So not only this very simple postcard-like card, but we have folded cards like this, which also have some bandage you put around it. I don't know how to properly call it. We have small booklets. We also have now photo calendars, which is a completely different deal, and products like this with like Polaroid-style photos. Now the problem is, with this growing software, all those new features, those new kinds of products, those new formats have been built into the same code base. And before I jump to the code, just a small disclaimer. I mean, it's very easy to make fun of code that others wrote, right? We all do that, and it's actually fun to do, especially if you don't know the original developer. But I guess we also have to keep in mind under which circumstances this code was written and for what purposes it was written. For a prototype, it's probably totally fine, but it really never left that state. So when the business became successful and grew, we kind of missed the point to say, okay, we've proven that it works, now we should implement it in a proper way. And here we are now 7 years later, trying to do exactly that. And we have a really complex code base now, which is really monolithic and procedural and yeah, all the bad things that you can imagine happened in there. So let's have a look. I mean, the first 20 lines we can probably ignore. It's use statements, that's fine. So apparently we're using some classes, which is at least something, right? But then it starts to become really ugly. I mean, setting PHP configuration values is always a symptom of, okay, something's obviously going wrong here, so we need to manually override memory limits and stuff. And in a normal configuration, you probably wouldn't even want to allow that in the runtime. Yeah, and then we see the requires, which is also not nice, especially require once is always weird, because that usually means you don't really know how often this code is executed. Like, normally a require should work fine, but this is also a really bad code smell already. But it gets way worse. So here's some actual code. So one thing we can see, we have this $_request, right? And that's bad in many ways. So first of all, it's global state, right? So we access a superglobal that PHP gives us with all the request parameters. So using global state always is a bad idea, especially when it comes to testing. $_request is even worse because it doesn't differentiate between if it is get data or post data. So you would have $_get and $_post for that. So it even doesn't matter what kind of request you send, even when it's a post request, as long as the parameters are the same, it works. So it's a very, it's really hard to see what the request should look like. So you can't even tell, should it be a get, should it be a post? But that's not the worst here. I mean, from a domain perspective, it's really hard to understand what's going on here. So apparently, like, we're looking at a format parameter here and we look if that is actually existing. If it does not, then we use template underscore format from the request. So, okay, obviously one of those two needs to be there, but we don't really know why. And we already have this comments up here, okay, deprecated, use format, not template format, and then a link to some Jira ticket, which obviously means some developer saw this, realized something's wrong here, created probably a ticket with technical debt. So somebody should look into this eventually, and left it to do here because he didn't dare to touch it actually and to really change something, so he just made a note. But at least that's something. And it goes on a while for this. So this is like, we're now on line 959 at the bottom. The script itself has 3,500 roughly, and it includes other PHP scripts, so overall it's a bunch of thousand lines of code. And it's still really hard to get what the actual intent is here, because, I mean, we check if a certain file exists. So we are looking for some input FO file. So since we know the domain a bit, we already know what the FO file is supposed to be. And if that is not there, then what we do, we make some static call to some IDML class, convert to FO. Okay. That actually kind of makes sense. So this line here, because we know that IDML is the source format where the card comes from. Now again, we have global state. We call a method statically. And what you can't see here, and what really is the worst actually in those lines of code, here we define some arrays. We are not in a class, so this is also completely in global scope. Now, when we call the convert to FO method on that IDML class, it actually relies on those arrays being present and puts data in there. So after we run this line, those arrays suddenly contain data. And then we continue working with that further down in the code. So this is in no way obvious. So if you open your IDE, let's say you open PHP Storm, you open this, it will actually probably tell you that those variables are not used or overridden somewhere down here. But you cannot rely on that because you have global state flying around and everywhere are references in other external files. So it's really a mess. And let's look at one more piece. So we are further down in the code. It's now line 2,700, whatever. And again, we are checking for some files to be present, and if one of those is there, or if it's not there, then we look at the next one. So we have some configuration path and some spot whatever PDF. Actually, right now, I don't know what that is. And if that's not there, then we check if it exists in another directory. And if that doesn't happen, then we don't even throw an exception. It's just an echo statement that we didn't find something. So when I first looked at that code, two things happened. First thing was, oh my God, I don't want to look at this. Please make it stop. Second thing was, and I believe that's typical for us, I immediately felt the urge to refactor stuff. So I got in there, oh, $_request, I need to change that. Okay, let's quickly create a request object and put that out. And the problem is, with a code base like this, it's almost impossible to just refactor stuff. And here's the reason for that. We put this bunch of lines of code into one class and wrapped it in one public method without changing anything else to be able to run PHP mess detector on it and get some code analysis. And this is very small, so you probably can't read it properly. But there's one pretty large number sticking out in the output, right in the middle. So that number is the n-path complexity. Who has heard of n-path complexity before? Okay, a couple. Essentially, the n-path complexity is the number of execution paths that your code has. With every condition you add to your code, the number doubles. I mean, you can obviously tell this is not a good number, right? And the warning threshold by default is 200. That's when PHP mess detector tells you to, okay, have a look at that you might want to refactor that a bit. So we stumbled upon this number, and it's obviously incomprehensible. And we were still curious, like, how would you actually, what's the name of that number if you want to put it in words? So we Googled for number to words converters, and most of them actually denied this because it's just a too large number. Eventually, we found one, and this is what came out of that. And I have never seen those words before, to be honest, like sexquintillion, I have no clue. I just think it's probably a correct naming for this number, so somebody at some point has invented those words. But I mean, even if you're really fond of numbers, and I don't know if you know that guy, it's Sesame Street popular here. Whoa, what happened there? Oh, cool. Anyway, so yeah, this is pretty bad, right? And with this high number of execution paths, there are so many conditions and so many edge cases, you can never be sure that when you refactor even the smallest thing, that you don't break something along the way. So we have a lot of global state everywhere. We have static method calls. Something's really behaving weird. And we have this huge amount of execution paths that make it pretty impossible to really understand what the code is doing under which circumstances. So in this case, we looked at the code and said, okay, it's not only hard to test legacy code, this is impossible to test. How should we ever test this properly? But actually, what we mean when we say code is untestable, we mean it's not unit testable. And that is very true. I mean, the end path complexity would also say, this is the number of unit tests you would have to write in order to cover everything. So we're kind of doomed there. But if we look at what kind of tests we actually have, unit tests are, of course, extremely important. They are the base of our whole testings. But we have a lot of other tests, right? We have integration tests, we have acceptance tests, and we have those end-to-end tests, maybe regression tests, depending on how you work with it. And why unit tests are really cool, because they are very quick to execute, and they have a low maintenance cost because they are not as fragile as end-to-end tests I maybe do with Selenium or something. It's really just one of the ways to test your software. And the more we get to the top of this pyramid, the more we get answers to the question, do we write the right software? Like, does it do what it is intended to do, what it should do? While the bottom of the pyramid tells us if we write the software in the right way, like, is this actually software we can maintain, that is robust, that we can test? So focusing on unit tests doesn't help us here. And I mean, obviously, we can tell by just looking at the code that we didn't write the software in the right way. So we don't need an answer to that question right now. There are exceptions, of course. So here's another like global code. Of course, it's a simplified example. And as usual, with simplified examples, it's very easy to test stuff. But we see we have just global code, no classes here. And something like that can be tested, and you could consider that a unit test. So all you need to do actually in your test is to require the original code, and it gets executed. It's not that much different from calling a method on a class. Anyway, in our case, this doesn't work. So the first thing that, or one of the next things that came to our minds was, okay, this is so bad, we don't want to touch that anymore. Can we please just do a rewrite? Just start on a green field with something nice. I mean, we essentially kind of know what our business is and what we need to do. So let's just do a rewrite. Problem with that usually is when you deal with legacy software, most of the time you don't have proper documentation. There we are. Probably don't have proper documentation, and if you have documentation sitting in some wiki, it's definitely outdated, as it usually is. So you pretty much only have the code. And without understanding what the code does, it's really hard to figure out what your new code needs to do, unless you want to also question all existing processes and like rebuild the whole business, but that wouldn't work. So there pretty much was no other way than, damn it, what's happening? than really, sit there, look at the code, and get into it and try to understand the gist of this code. And what can really help us there is using end-to-end testing, because that is always possible. No matter how badly written your code is, you can always use end-to-end testing, because essentially it's nothing else than just sending a request as a normal client would do. So that always works. So with establishing end-to-end tests, we can at least tell that the software does what it is supposed to do. And that would be already really cool. So if we look back at what this particular software does, or this code, this is one of the two core processes it does. At least that we already knew. So it's not only dealing with like one task, take this IDML file, convert it to an FO file, but it's also dealing with, hey, the customer changed stuff, so recreate the FO with the customer data. So two completely different use cases in one code base. But we can start focusing on one, which would be this one, taking in some IDML file and producing some FOP XML. For this, we can come up with very simple tests, which are not nice and not clean, but will at least give us some information here. So this is a very simple end-to-end test that manipulates global state, which you normally don't want, of course. So we actually override stuff in the global $_request array. Then we require this code, which has this nice name, template new, by the way, which also doesn't say as much. And since we provide a certain request state, or simulate that, the code will behave as if we send the actual request with that data. And since we know that it is supposed to create an FO file when I put in a certain IDML file, I can actually make assertions. Since the code is in production, it already created a bunch of FO files for certain cards. So I take one of those existing files because I know this is the one that I need to get out of there. This is the correct output. Put it in some directory, then run the code with the same parameters as I would do in production. And I look at the file that's created during the test run. And ideally, they should match, right? They should be identical. Then everything works as expected. So here's one example with just one product we have. That's an SKU, and the format describes if it's a postcard or something more sophisticated. It's not too important right now, but this already tells us for one card, does the code actually create the correct FO file? Of course, one card is really not enough because we have, I don't know, hundreds of products. But actually, it's not too hard to extend that with a data provider. And just do the same here, but inject the relevant parameters and get them from some data provider where I have all my relevant designs and SKUs and formats. And always look if the existing or the new FO file actually is the same as the one I expect. So this already gives us some certainty that at least in this one use case of taking a certain format and putting out in another format actually works properly. So I probably can start making slight refactorings now. There are cases which are even worse than that, because sometimes if you want to enter into a certain part of code, you not always know what the actual required parameters are, what comes in production and what goes out there. There's a special kind of test for that, which is called characterization test. And this is the attempt to figure out existing behavior in a system that you don't really know and where you don't have as much insight into. So this is usually Sebastian's part because he created a project. And the name is a bit misleading because delegacyfy kind of, well, at least I would think, okay, I can run this over my code and it will make it new and nice and not legacy anymore. Of course, that's not what it's doing. What it does is actually executing code. Well, not quite. So you run legacy code and you use Xdebug to create a trace of what you did. So you can run this in production. You can actually enable Xdebug on one of your web servers, for example. Click to your site and do whatever you need to do for a certain process. And Xdebug will create a trace out of that. And it looks a bit cryptic. It's what we see here in the middle. But this trace dump then can be used by this delegacify tool to create a data provider for PHP unit. This still looks a bit cryptic. But essentially what it does is the trace now contains function calls, and the function calls also contain all the parameters that have been passed in and the return value that came out of that. So I have a recording, essentially, of all my function calls. And this I can use as a data provider now and create a very simple function that, or test function that calls my code with the data that came out of that Xtrace dump. So I can pretty much replay what I recorded in production and make assertions during a test. Now, this is probably relatively fragile, but it might help you to get started if you really have like nothing to work with. You could do a recording, use Xdebug to get the trace, and then replay it with PHP unit, so you get a rough end-to-end test scenario there. Now, luckily, in our case, we didn't need that. It wasn't that bad. So we already have our end-to-end tests now, so we can at least tell that one of the most critical processes works. Granted, we couldn't cover all the edge cases, mind all the execution paths. But for a certain set of products, we can already tell that the code still produces the right output. So one of the next possible steps would be, since we now have end-to-end tests and some kind of certainty, I can go into the code and start refactoring it so it is actually more testable in terms of integration testing. That could mean, as we already did for the analysis, first of all, move all that procedural code into one class, create one public method. If you have global functions that are being called, move them over to private methods, ideally in the same class, if possible. Don't touch the rest. That's still the same ugly code. It's still 3,000 lines, but at least you already have a class construct around it. And that very quickly enables you to do something like dependency injection. So we can start to move out the request as a separate object that comes into the constructor. So I can relatively easily get rid of the global state, don't use the super global anymore, but have an actual API. So I have a concrete class for this kind of request that offers me an API to retrieve the format, the design, and so forth. If a parameter is not present, I can then properly throw an exception in that request object. I don't need to make any quirky checks in here anymore. And of course, having dependency injection then also makes it possible to do integration testing, because I can start to mock away the outside world. Not completely, obviously, but I can create a mock of this IDML parser, for example, that I have up here and up here. So I don't need to run the actual parser anymore. I can start to make stubs and mocks and make the tests smaller and more robust. So if we can make that switch and actually are able to go into the level of integration testing, we're getting closer to having a software that actually is written in the right way. Of course, that's a huge journey if you look at that code. But if we have integration tests there, refactoring the code base is at least doable. It's not pleasant and it's not easy, and it will take a long time probably, but at least you get a base now for actually doing that. The question is if you really want that. And in our case, we didn't. What we wanted to do was really understand the code to be able to come up with something new. Now, with the end-to-end tests alone, I already have a subset of products that I can make tests on. So the pattern that now helps us there to get to write new code is branch by abstraction. So in a normal setup, in our case, there's some web server sitting, and there's a legacy code base, and it's a one-to-one. So every request gets sent to the legacy code. In branch by abstraction, one of the possible ways to do this is to put code in front of the legacy code that takes in all requests, And by default, it will just pretty much forward the request to the legacy code. It will not do anything. It's really just as a proxy. But I can add logic there and say, okay, if the request has certain parameters, let's say we have a certain card format, like the postcard, then I will not send the request to the old code, but I will send it to something new that will deal only with this one specific format, this one specific product, and all the rest is still handled by the legacy code. There are several ways to implement this. You can easily implement this on the application level, of course, so you can put some PHP code in front. You can also do that on the web server level with Nginx, for example. You could do some Lua scripting in there that actually looks at the request data and makes decisions based on your request data. What's also very feasible and maybe the most flexible one is to put the logic in the new code and have the legacy code act as a fallback. So your new code could say, okay, I cannot handle this request, I will forward it to the legacy code. So you kind of remove the abstraction layer and send all requests to the new code first. That depends on how you want to deal with this. For us, this works great because this legacy code is pretty monolithic, right? It does many products, all different kinds of formats, and you can probably imagine that for creating a calendar, there's a lot of other stuff going on with calendar dates being correct, and for what year is this? You don't need that for cards, so why would you put that in the same code base? So we can actually now create multiple new applications, small services maybe, that only deal with certain product types. So we have one part of code that's only dealing with calendars. And there might be redundancy because there are shared processes, but still we want to have this separated and not have this one huge application again that does everything for us. What is also very helpful when you have end-to-end tests and probably or even already integration tests is using the code coverage report. Hello. Because the code coverage report will tell you which parts of this ugly code have actually been executed when you run a certain end-to-end test. So when you say, okay, I run the test for a certain kind of product, and I enable the code coverage report, then I can see which parts of the code have actually been executed to create the matching file for this one specific product, which means chances are high that you can pretty much ignore everything that has not been covered when dealing with this one particular product. So if I want to create a new code that does this one specific format, I can enable code coverage and see, okay, for this format, I have maybe 250 lines of code that are actually executed. All the rest is dealing with edge cases for other formats, for calendars, whatever. I can completely ignore that, so I can move over that code and then start dealing with that. And suddenly it becomes actually understandable. Now, of course, if you go the other way around and you want to really refactor the existing code, you can do that because, well, when you have refactored it properly, you get to the state where you can do unit testing. The dependency injection already helped. You will still get into trouble with all the different conditions. So if you have a high end path complexity, that won't help you, probably. So in our case, that really wasn't helping at all. So we decided not to go down that road. So to do some conclusions already, what was really helpful for us when doing the testing, we didn't write end-to-end tests to figure out if the software does what it should, because it's been running for 7 years, and since developers normally don't touch that piece of software because they don't want to, we can say it's doing what it should do. So we know that the software does what it's supposed to do. We don't need to test that, really. But what it did for us was providing a source of documentation, actually, which was really helpful, because if you start having proper tests and start having the code coverage report, you suddenly have a tool that really tells you how you can deal with the software, what pieces of code you need to look at, which ones you can completely ignore and are not relevant for your current case. So that was really good. Also, establishing this end-to-end test is what actually allowed you to write the new code, because you can run the same end-to-end tests on the new code, and they should produce the same result. If they don't, you did something wrong. So you have a very easy way of verifying that what you do is actually still behaving the way it should. If you go one step further and do the integration tests, then you get into the possibility of refactoring your code to make it really modern and unit testable. If you don't want to go that road, have a look at branch by abstraction. It's actually a very simple way of gradually moving out functionality from legacy code. And that works on many levels. You can do that with a whole application. So we also did that with an e-commerce system, for example. Our shop system, we also replace piece by piece, not the whole system at once. That would be too much. So we have some abstraction layer that really says, okay, this is a category URL. I don't send this to the old shop anymore, but there's a new system that will show a category page. If I go to the basket, well, that's dealt with by the old software again. So that works really well. And this is really the most important pattern that we use to be able to really get rid of legacy code piece by piece and not have this huge rewrite that nobody can really estimate how long it will take. And obviously, I mean, if you do write the new code, this is where you add your new foundation of unit tests, have the integration end-to-end tests on top. But obviously, if you write new code and establish that, you want to have the unit tests there to not get into the same situation 7 years in the future, right? And luckily, if you get to that state, that's pretty doable because then you have clean code again. And then testing becomes easy again. And you can apply everything that you learned about unit testing, which is actually pretty fun. All right. Well, I'll switch to the next slide, but we have plenty of time for questions. If you have questions, please raise your hand and wait a moment because there will be a microphone taken to you, so it's on the recording. In the meantime, the QR code is the one to the joined-in session, so I'm always happy for feedback. Yeah, there was one question.
So how do you get, if you have a tech lead who is not very supportive of adding tests to your software, legacy software, how do you get them to adopt testing?
That's a pretty tough question. So, well, first of all, luckily we didn't have that situation. So the original developers who did the legacy code we looked at are long gone. They're not part of the company anymore. So we have a new in-house team, and when they came to us, they already were, used to do tests. So we didn't really have to advertise that. I think most of the time it's not really about getting the developers on board. I find that easier than getting business on board. That's where I usually see an issue, like selling it to the business. Is it really worth taking the extra time to write tests and everything will take like double? In both cases, there's a great study, unfortunately it's not in the slide deck, about the relative cost of a bug fix, which is something that I think really helps when you try to find good arguments for doing testing. And what it does say essentially is that in your overall process of writing software, like you're designing software, you're writing it, you're doing QA, you're doing regression tests, and you're putting it out live to your customers. The later you find bugs, like in the later state, the more expensive it gets to fix them, which is kind of an obvious thought, but the cost actually is rising in an exponential way. So, of course, it's the cheapest to find a bug in the design phase because you think, okay, we wanted to write this class, but that doesn't make sense, so we have to do it in another way. If your customers have to discover a bug, and I mean, even if you're lucky enough that they report it to you, because most of the time they just don't buy, for example, if it's an e-commerce site, that gets really expensive. And that's really measurable in money, like how much money did I lose because of this bug, because people like bounced off my site. So you want to find bugs as early as possible, and testing is definitely one of the easiest ways to establish that, to make sure bugs don't get to production. That's one thing I usually start with. Hope that answers your question. Yeah, then back.
Hi, I wonder if I could just offer a little reflection, which I think completely supports what you're talking about. Right at the beginning, you showed us the initial 3,000 line code, and you said your first response, and probably a common one, is to get in there and do some refactoring. And it's interesting you should use the word refactoring, because some people consider that the definition of refactoring is changes supported by tests, which at that point you didn't have tests, so it actually probably wasn't a proper refactoring. But then your whole talk is about how you would actually provide those tests so that we can actually respond to our instinct in the proper way. So I just wanted to make that observation, because that's what I took out of it. I don't think you ever said that explicitly at any time, but by putting those end-to-end integration tests in, you're actually able to respond correctly to what you want to do.
Yeah, absolutely. Yeah, thank you for that.
Any more questions? Any more questions? No? Oh.
There's one.
Excuse me. Do you have any dependencies on external APIs in any of this code? And how would you write tests that depend on a system you might not have control over and could potentially break your codes and make your code look broken when it's a separate system that's at fault?
Yeah, we don't have external dependencies. We do have dependencies to, let's call it services in terms of command line tools. But yes, if we had like an external API that, I mean, there are more complicated examples when it gets to e-commerce, for example. So, I mean, placing an order in an end-to-end test is problematic if you do it on live code, obviously. Although on our case, since we do have, I mean, we all have test environments and staging environments, so running it there normally doesn't do any harm. An end-to-end test is really that. So if you have external APIs that are being called, the end-to-end test will not help you there. It will do the call, because it really is the same behavior if you did a real request to the application. There's no difference. So you can't really get around that in an end-to-end test. You can get around that in what you could call edge-to-edge. So you don't take the whole process, you don't send a real request, but you just use a small part of the application, if that's even possible. Any other way, you will need to have to come up with integration tests that allow you to mock away the API. So there's probably no real way around then going to a place where you can introduce dependency injection and then, well, inject the mock of the API service client.
Related to the testing with APIs, you could actually use PHP VCR, which then you make an annotation in your PHP unit, and then everything which is like file get contents or curl requests, they can be all recorded and then played back afterwards.
Cool.
So that's a possibility for your use case.
Yeah, cool. I didn't know about that. Thanks.
All right. Any more questions? All right, I think that's time. Well, round of applause for Sebastian.
Thank you very much.